The next example problem that I wanted to do was a chi-square test for independence. This comes from Chapter 11, Section 3. And the chi-square test for independence has one population, and the question is there any relationship between the two variables that I'm interested in? Two variables, one population. I want to know, is there any relationship between those two variables? If I know the value of one, does it help me to predict the value of the other one? Okay? If they're related, the answer is yes. If they're not related, the answer is no. So here's some data. This is from page 404, problem 1124. It says, how many airline loyalty programs do non-business travelers belong to? A study by Perigo Incorporated revealed the following results. So notice we have the contingency table again. So that tells me probably going to be a chi-square test. But I need to notice the question to see exactly which form of chi-square test I need to use. It says at the 0.01 level, so I've got to use 0.01, is there evidence of a significant, here's the key word, relationship between the number of airline loyalty programs and age? So I've got a sample of 1,180 people, and what I want to know about is, if I know what their age is, does that help me to predict how many loyalty programs they're likely to be a part of? All right? So, is there a relationship between the number of loyalty programs and age? That's the question I'm trying to answer. So again, I've got one population, I've got two variables, number of programs and age, that I'm interested in finding out, are they related or not? So step one, going through my 6 steps. What is the null and alternative? There is no significant relationship between the number of programs and age. Or you could say, alternatively, age and number of programs are independent. The alternative is there is a significant relationship between number of airline loyalty programs and age. So there is a relationship, or they are dependent. These two variables, number of airline programs and age, are dependent. Step 2. What level of significance? 0.01, because that's what it told me in the problem, and n equals 1180. Notice I have one sample, and I have two variables that I'm interested in, but all these data come from the same population, so I don't want you to tell me, a different number. It's going to be this lower left-hand number is the total number in the sample that we've taken, 1180. Okay? Step 3, what test statistics should I use and what sampling distribution should I go with? So, I've got a contingency table and I'm interested in two variables, so I want to use a chi-square test. These data do not need to be normally distributed. Anytime I have chi-square, I do not have to have a normal distribution. What I do have is several categories. And these categories are telling me how many loyalty programs people are part of and what their age grouping is. Okay, so those are categories that we're looking at. So I've got a group of categories here, a group of categories over here, and so what I want to know is there any relationship between those two things? I do not have to have a normal distribution, and I'm looking at numbers in the contingency table for each of those variables. So here's my Excel results. And again, I'm using a chi-square test, and I have number of loyalty programs in one direction and age in the other direction. And all we've done is we've input the data that was given right here. These numbers are now in the Excel PHStat program right there. It will give me the expected values that correspond to each of those cells. It calculates that automatically. One of the things to notice there, remember, is expected values for chi-square have to be at least 5. So if I check these cells down here, I've got a 6.5, I've got an 8.25, 14. Now this last group is below 5. That looks like it may be a problem for me. I only had 8 observations, 8 people that said they're in 6 or more loyalty programs. So what I probably need to do there is to collapse those categories to make it 4 or more loyalty programs. So I'd add these numbers together and combine all these numbers. That'll take care of my expected value problem there and will give me the correct results. All right, so level of significance, remember, is 0.01. Number of rows and number of columns. Right now we have 1, 2, 3, 4, 5 rows, 2, 3, 4, 5, 6 columns. So what will probably happen is whenever we combine rows and columns there, we're going to end up with one less row. 1, 2, 3, 4 rows instead of 5. You don't count the totals, so you only count the individual values. So you'd have one less there. And that's going to change my degrees of freedom a little bit here, and also my critical value. All right, so probably I should just quit where I am because we've got to go back and fix that. Okay, so there's my critical value test statistic. I'm going to reject the null. There is a relationship.